Greetings, students. I am going to do a couple of example problems with impulse today. So I have my first problem in front of me, which is a truck originally going 20 meters per second with a mass of 2,500 kilograms collides into a tree with a force of 30,000 newtons. How long does it take this collision to occur? So we're looking for time, all right? And things that we're going to need to remember is that force times time is the same thing as your impulse, but also impulse is your change in momentum. Okay, so I'm going to use an if chart to help me solve this. We're actually going to use all three charts today because I originally have going 20 meters per second and it has a mass of 2,500 kilograms. So that means that I'm going to have an area like this. This is going to be my initial momentum. Okay? And then at the end, I don't have any momentum because it's collided into the tree. So that means that it has crashed and it is at rest. So I still have that mass of 2,500 kilograms, but it's not moving anymore. So I'm just going to put an X. This is a pretty clear indication that a collision has occurred and I'm looking at one object. So I should have a force time graph. I'm given that the force is 30,000 newtons, but I have no idea what this time is. Okay, so and remember, this is going to be my final. So I know that my J is my change in momentum, which is my final momentum minus my initial momentum. And if I plug in my formula for momentum, that's mv final minus mv initial, which I can rewrite as mass times velocity final minus velocity initial. So I can factor out the mass. That makes solving a little easier. I also know that J is equal to force times time. So I could say force times time is going to be equal to that mass times velocity final minus velocity initial. This is the key thing. If you can set this part up, you should be able to solve the rest of the problem without any issues. If you can do algebra. Can you do algebra? We're hoping. So I'm looking for time, so I don't get t by itself. So I'm going to move me. I'm going to move my algebra over here. And I'm going to say, getting t by itself, that time is equal to mvf minus vi divided by f. So I just divided force over the other side, plug in my values. So my mass is 2,500. My final velocity, I don't know why it's so pointy on here. My final velocity is 0. My initial velocity is 20. And I'm going to divide that by 30,000. So it's going to be a really small number. If I pull up my calculator, 2,500 times 0 minus 20 all over 30,000. And I get a time, and it's going to come up as negative. That's because we didn't account for the fact that when the car collides, that force is experiencing is backwards. So I really need to make this a negative 30,000, and I need to go back and change my F chart here to make it so that my force is negative. That's going to make much more sense. So this is going to be negative 30,000 newtons. And that's going to give me a value of 1.67, it's 1.666 repeating, seconds. So fast, but really not as fast as you think it would be. So this is just a first example. This is actually kind of a simple example. I'm going to do a couple more. This one I solved for time, so I want to be able to solve for force, and then another one I want to be able to solve for a velocity. So that's what you can expect to see in the other two videos.